Welcome to this video. I am Physics and today we are going to be going over current, charge, voltage and resistance. So first of all we are going to be looking at current and charge, where current is the rate of flow of charge which is measured in amps using an ammeter. Charge is a property of matter which experiences a force when put into an electric field, which is measured in coulombs. I equals change in Q over change in T, where I equals current, Q equals charge and T equals time. So voltage is the difference in electric potential between 2 points in a circuit and is the energy carried by the flowing charge. It is measured in volts. V equals W over Q. W can also be written as E as well. So where V equals voltage, W equals energy/work, and Q equals charge. Resistance is the measure of how difficult it is for current to flow. It is measured in ohms. R equals V over I, where R equals resistance, V equals voltage, and I equals current. So now we are going to be going on to the GCSE exam style question, where it states, calculate the total charge that flows while the battery is still being charged. So we have the information in the question which states that the potential difference is 330 volts and can store up to 64 megajoules. It takes 8 hours for the battery to fully charge and it is 100% efficient. So we need to find a formula that relates charge, energy and voltage. And if you remember, it's the previous one which is over here, where V equals W over Q. So in this case, I'll write as E instead of W, as it's energy, not work. And so we need to rearrange for charge. And when we do that, we will get E over V equals Q. So we'll have, but don't get caught out, as it is 64 megajoules. So instead of 64, we're going to do 64 times 10 to the power of 6 joules. So 64 times 10 to the power of 6 joules divided by 330. And when you do that, we should get 193,939.4. And that's the answer. Coulombs. So now part B is calculate the average charging current. And we know that, so we have the charge and we have the time. And what formula relates all of them? It is I equals Q over T. And we need to find the current. So we don't need to rearrange as current is already on one side. So we just need to do 193,939.4 divided by 8 hours. But we want that in seconds. So to go from hours to minutes, and then minutes to seconds. So to hours to minutes you have to times by 60, and minutes to seconds you'd have to times by 60, and so altogether you will need to times it by 3,600. So we have to do all of that divided by 8, as there's 8 hours, times by 3,600, as there's 3,600 seconds in an hour. So when we do that, we'll get 6.73, and that is your answer, 6.73 amps. So now we are going to be moving on to the A-level exam style question, where it states calculate the energy transferred by the lightning strike. And it says that the potential difference is 2.7 megavolts and it produces a current of 25 kiloamps in a time of 7.5 milliseconds. And we need to find the energy transferred by the lightning strike. So we have the equations V equals E over Q, and we have the equation I equals Q over T. So in the question we're given the voltage, which is over here. We're given the current, which is over here, and we're given the time, which is over here. So over here we can find the charge if we rearrange the equation, and using this charge we can sub it in to over here and we can find the energy. So first of all we need to rearrange this equation over here to get Q as a subject. So Q will equal IT, and so we have to, and when we do that, 25 times, but you shouldn't forget that it's kiloamps, so you have to do it times by 10 to the power of 3 times 7.5, and as it is milliseconds we have to do it times 10 to the power of minus 3. So when we do that we'll get 187.5 coulombs. And so now we need to sub that in to the Q of this equation and make E the subject. So when we do that we'll have E equals VQ, and we need to do the voltage, which is 2.7 megavolts, but as it is mega we need to times it by 10 to the power of 6, so 2.27 times 10 to the power of 6 multiplied by the charge that we just got, which is 187.5, and when we do that we will get 506.250,000 joules. Don't forget the units as it's not given in the question. So 506.250,000 joules. And that's the answer. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.